The Cryochamber system delivers cold exposure through whole body or localized cryotherapy. The cylindrical chamber includes a digital display interface and operates at sub-zero temperatures, as indicated by visible vapor release during use. The Cryoxc Plus was introduced in 2021 by Cryony QSRO, based in the Czech Republic, and is distributed in the United States by CryoBuilt Inc. Although it is not approved as a medical device by the FDA, it is marketed for wellness and recovery applications. The chamber operates between -110 and -150 degrees Celsius and is used for sports recovery, pain relief, inflammation control, and circulation enhancement. The outer shell is constructed from stainless steel or anodized aluminum. Inside, multi-layer polyurethane foam provides thermal insulation. Cooling system tubing is made from cryogenic-grade stainless steel or copper, and the seals and door gaskets are composed of silicone or EPDM rubber to maintain airtight integrity. The chamber's insulation combines aluminum and polyurethane layers to maintain sub-zero conditions. Cooling is achieved using either nitrogen or electric refrigeration, with temperatures ranging from -110 to -150 degrees Celsius. Thermocouples and infrared sensors monitor internal conditions, while a touchscreen control panel manages session timing. Air circulation ensures uniform cold distribution throughout the chamber. Temperature regulation is maintained by a PID controller, supported by thermocouples, RTDs, and infrared sensors. Airflow sensors confirm adequate cold air delivery, and oxygen sensors monitor breathable levels inside the chamber. A door interlock prevents operation when the chamber is open, and an emergency stop allows immediate shutdown. Humidity sensors detect moisture buildup, and session parameters are recorded through a data logging system. Cryotherapy operates on heat transfer and thermodynamic principles. Convective heat loss between the skin and cold air is calculated using surface area, heat transfer coefficient, and temperature difference. In localized cryotherapy, thermal conductivity governs heat conduction through tissue layers. Total body heat exchange is quantified using mass, specific heat, and temperature change. Thermoregulation during exposure relies on controlled convective and conductive cooling. In this analysis, the chamber temperature is set at -120 degrees Celsius, while skin temperature is 30 degrees Celsius. With a heat transfer coefficient of 25 watts per square meter per Kelvin and a surface area of 1 square meter, the resulting heat flux is 6750 watts. Over a 180-second session, total energy removed equals 1.215 megajoules. The estimated cooling depth is 5 millimeters, based on thermal diffusivity and exposure time. Assumptions include one-dimensional heat transfer, steady-state conditions, and a resting body. Exposure to extreme cold triggers vasoconstriction, redirecting blood from the extremities to vital organs. Nerve conduction velocity decreases, which reduces pain perception. Cold exposure also stimulates the release of norepinephrine and endorphins, enhancing mood and energy levels. After the session, vasodilation causes reactive hyperemia, increasing oxygen and nutrient delivery to tissues. Whole-body cryotherapy operates between -110 and -150 degrees Celsius for 2 to 3 minutes, targeting the entire body. Localized cryotherapy ranges from -20 to -60 degrees Celsius and lasts 5 to 10 minutes, focusing on specific regions. Whole-body therapy induces systemic vascular rewarming, while localized therapy relies on direct conductive cooling. Whole-body systems are typically found in spas and athletic centers, whereas localized systems are used in physical therapy and dermatology. Assembly begins by attaching the base platform and securing the outer shell panels. Cooling tubing is connected and sealed, followed by installation of internal insulation and the interior lining. The control panel is mounted and sensor wiring is connected. Disassembly involves powering off the system and venting residual nitrogen vapor, removing sensor wiring and control panel connections, detaching the door and gasket seals, and extracting the cooling tubing and insulation layers. A visual inspection is performed to check for wear or corrosion. Daily maintenance includes checking for frost or moisture buildup, while monthly maintenance involves verifying sensor calibration. Cryotherapy is contraindicated for individuals with cardiovascular disease, hypertension, or Raynaud's syndrome. Exposure duration is limited to 2 to 3 minutes, which restricts treatment intensity. Improper use or system malfunction may result in skin irritation or frostbite. Engineering limitations include high energy consumption, reliance on nitrogen or electric cooling, and the need for precise sensor calibration. Clinically, the device is not FDA approved and lacks long-term efficacy data.